This is page 5 of the notes for Volumes of Revolution. To get started with this, one thing before we actually get into this problem right here, just to kind of show you all the different styles, the 4 different types of problems that you'll see, pretty much is we have to make sure we understand what is rotating around a vertical line and a horizontal line. And so a horizontal line, okay, it's going to be y equals, and so what that leads to is an integral with x equals disk or washer dx, and then your equations are going to be y equals along with your axis of rotation will also be y equals. So if you know what the axis of rotation is, it kind of gives you a clue as to how everything should be set up. If it's a vertical line, okay, your axis of rotation is x equals. Whereas over here for the horizontal line, your axis of rotation is y equals. So for a vertical line, axis of rotation is x equals. So that tells you then your integral is going to be y equals. And you're going to be y equals. It'll be dy. The equations, okay, the equations are going to be x equals. Now, this one, rotating around a horizontal line, we rotate up, down, top, bottom. For this one, you're going to rotate left, right. Okay, so we're going to take a simple kind of equation, square root x. We're going to have these other lines, y equals 0, x equals 4, and we're going to try to rotate it like around 4 different types of lines so you actually see how they are. X-axis, y-axis, x equals 4, y equals 2. All right, so first problem, okay, this right here, we're doing A is going to be your axis of rotation is y equals 0. When you deal with that, x-axis y equals 0, what's going to happen is your shape, so here is your shape, here's your square root. What it's going to look like is you're going to rotate it down here around the x-axis, and it's going to create what we call a disk-like situation. And so this right here would be your r, and it'll go from x equals 0 to x equals 4, because that's where we're going from this. All the way to 4. And it'll be pi r squared. And r in this case is the square root of x minus 0. Don't forget the squared part a lot. Again, a lot of people forget that squared part, dx. Okay? And your cone is going to be circular, kind of like this. Kind of like what we just did in all our examples. All right, next one. For part B, we are rotating around the y-axis. So this is where it gets a little bit different in terms of how it looks. Here's my square root. What we do is we copy, we reflect that over our line of rotation, axis of rotation. You're going to see that there's going to be kind of like this empty space here. Okay, so this is all filled in, this is all filled in, and so you have some empty space here, this right here. All right, so let's kind of figure out what this will be. So this right here is a line, let's see, it's the y-axis. So this vertical line right here is x equals 4. So let's actually try to maybe do a different color. Okay, so just so it's a little bit clearer, this line right here, x equals 4. This right here, axis of rotation, x equals 0. So axis of rotation, x equals 0. All right, so what's going to happen is we have to figure out what our two different radiuses are, because you see how there's an empty space here between. So we know that this technique is going to be a washer technique. So we need 2, right, pi r squared minus another pi r squared. So this right here would be my little r. Okay, so little r is going to be 0, or actually, when dealing with stuff in the y direction, the one that's kind of like further to the right, so further to the right is going to be kind of like your quote unquote top function, and the one that's to the left will be your lower function, okay? So in this particular case, it'll be the square root of x minus 0, okay? Now, what do we know about the square root of x though? Is that what it's supposed to be when we rotate around in the x with a vertical line when we do things with respect to y? Nope. So this right here, we need to rewrite. So instead of y equals the square root of x, remember our equations have to be x equals. So this gets turned into x equals y squared. Okay? So taking our little eraser here, erase this, and what this will be is y squared. Okay? Because remember, our equations have to be x equals. All right, the next part. The next part is trying to figure what the big radius is. And the big radius, I'll highlight in green here, this right here is the big radius. This is big R. Now, big R, okay, is this equation, x equals 4, x minus x equals 0. So in this particular case, it'll be 4 minus 0. Essentially, when you revolve this solid green line, you create a cylinder. This right here is kind of like a circular curvy cone that you're cutting out of that cylinder, and whatever's left is your volume. So that's why this one, anytime you see something without a variable, it's going to be kind of like a solid cylinder, like can. And then this one will be a kind of like a curvy cone that you're cutting out of it. So your final answer then will be something y equals, you're going to have pi big R squared minus pi little r squared. So in this case, it's going to be pi 4 minus 0 squared, so that's like a cylinder, minus pi y squared minus 0 squared dy. All right, so where does this go to? Well, the y value at the bottom part here is 0. What's the y value? What's the highest y value? Well, this point here is 4 comma 2. Square root of 4 is 2. So the y value here is 2, so we're going to go all the way up to 2. So there is your volume. Okay, let's go on to the next one. The next one is... So the next one will be C. Okay, we are revolve around x equals 4. Now, x equals 4, great. Whenever you're given this kind of stuff, you know your axis is x equals 4. That kind of gives you a clue as to what type of integral we're going to be doing. because x equals 4 is my equation, my integral is going to be y equals dy, and my equations obviously are going to be x equals. Okay? All right, so let's actually draw a picture of what this thing would look like. So here's my graph. Here's x equals 4. We are doing a volume of revolution. So there you go. There's my square root. Okay. Over here is what it would look like on the other side. We're revolving around this particular spot. So we're revolving like this. Now, as we revolve around this, if this whole shaded area is revolved around this, hopefully you'll see that there is no so when we revolve around this way, what you would see is that there is no empty space here. Okay, so there's no empty space as we revolve. It's going to be kind of like a Nilla wafer. Okay. I'm hungry now, but yeah. So going to be kind of like a little flat little mound. But it's not going to be hollow. Okay, so what this is telling us is that this will be a disk technique. So all we need is one single pi r squared to kind of do this one. So it'll be y equals. Now we are going from, remember, y equals. So we're not looking at the x-axis anymore. We're looking at the y-axis. If you recall, this was 4 comma 2. So we know that our limit's going to be 2. It's going to be from 0 all the way to 2. All right, so let's take a look at our radius now. Because we only have one radius, remember, we're going from the function to the axis of rotation. So this right here is r. Okay, so this right here is r. Not the y-axis, because that's not our axis of rotation. It's this function and this function. So which one is on further to the right? That's the one that goes first. So in this case, this will be pi. Now to figure out what r is, it's going to be x equals 4 minus y squared. Okay? Because over here, the further one to the right is the axis of rotation, so it's going to be 4. The one further to the left is y squared. Okay? Because remember, this is x equals 4. This right here is x equals y squared. All right, give it a little bit of thickness. Now you have your volume. Okay? Now, a couple of things. Let's say in the notes, if it said y squared minus 4, technically that's a little bit off, but because you're squaring anything, the answer will still come out to be positive. So 4, let's say 9 minus 4 would be 5. 5 squared would be 25. If you did 4 minus 9, you would get negative 5, but because you're squaring it, you'll still get 25. So it's not really proper to put the y squared. I know I did that in my notes, but technically it should be 4 minus y squared. But because we're squaring it, in the end, it'll come out to be still the right number at the end. So you're going to be okay. Okay, but it should be when you're doing with respect to y, the one on the right minus the one on the left. Okay, in the x direction, if you're going top and bottom, it's the one on the top minus the one on the bottom. Okay, last one. Let's get this guy done. For part D, we are rotating around y equals 2. So here's our function. Let's see. Actually, do this because you'll see it better here. So here's my square root. We're revolving. This point right here, if you recall, is 4 comma 2. Now, the axis of rotation is actually this guy right here. Okay, your axis of rotation. Y equals 2. What does my shape look like then? If I revolve this around the y-axis, you'll get something like that. And you can kind of see that there's going to be this empty gap right here when you do this revolving around this line right here. And so you're going to use the washer method. Okay? And so what this will be, you have to figure out what your functions are going to be as they relate to the axis of rotation. So in this part right here, this right here would actually be little r from the axis to the inner function. The outer function would be something like here, from this point all the way down to the x-axis. That would be your big R. Okay, so our big R would be 2 minus 0. Okay, so y equals 2, y equals 0. My little r would be the axis of rotation minus this right here, the square root of x. So this is y equals 2 minus y equals square root of x. So those are your two radiuses. Well, you're practically done then, because your integral will be x equals 0 to 4, and then you have your pi big R squared minus pi little r squared, which will be pi 2 minus 0 squared minus pi 2 minus square root x squared dx. And then you can just pop that into your calculator and kind of figure out what that area is going to be. All right, one last thing to note just really quick is the following. Sometimes this is a very common mistake that kids do. They try to simplify things a little bit too much. Pi r squared minus pi little r squared is not the same as pi big R minus little r squared. Okay, because pi, if you multiply this out, this would be r squared minus 2r little r plus little r squared. Not the same. So this right here is not the same as this. A lot of students do this mistake. They try to combine the little radiuses together. It's two separate problems. The most you probably could do is something like this. R squared minus r squared, little r squared. You always do the r squared separate from each other. Okay? All right. I'll see you guys later.